Imagine gazing up at the night sky, where the twinkling stars seem close enough to touch, yet each one is a distant sun, millions, or even billions of miles away. Beyond our solar system lies a universe teeming with mysteries, alien worlds that could harbor life, swirling nebulae where stars are born, and black holes that defy our understanding of space and time. What secrets do these cosmic wonders hold? Are we alone, or is there something, or someone, waiting to be discovered in the vast expanse of the cosmos? Join us as we journey beyond the familiar planets and moons of our solar system to explore the infinite mysteries of the universe. The night was clear, the kind of night where the stars seemed to hang low, as if they were within arm's reach. A young girl named Leela sat on the roof of her grandmother's house, her eyes fixed on the heavens above. Her grandmother had always told her stories about the stars, how they were not just points of light but suns, some with planets of their own, and how, somewhere out there, the universe stretched beyond imagination. "What's out there, Grandma?" Leela had asked one evening, her voice filled with wonder. "More than we can ever know, my dear," her grandmother had replied, her eyes twinkling like the stars themselves. "More than we can ever know." That conversation had sparked something in Leela, a curiosity that would shape her life. Years later, as an astrophysicist, she found herself standing at the edge of human knowledge, peering into the vast unknown. This is her story, and the story of humanity's quest to understand what lies beyond our solar system. Leela's journey began with the familiar, the solar system. She knew it well: the sun, a fiery ball of plasma at the center; the rocky inner planets, including Earth; the gas giants like Jupiter and Saturn; and the icy realms of the Kuiper Belt and Oort Cloud. But beyond Pluto, beyond the reach of even the farthest human-made object, Voyager 1, lay the interstellar void. Voyager 1, launched in 1977, had crossed into interstellar space in 2012, sending back data that fascinated scientists like Leela. It revealed that the boundary between our solar system and the rest of the galaxy was not a sharp line, but a turbulent region where the sun's influence waned and the interstellar medium began. "It's like stepping out of a warm house into a cold, windy night," Leela explained to her students. The solar wind, a stream of charged particles from the sun, creates a bubble around our solar system called the heliosphere. Beyond that, the interstellar medium, a mix of gas, dust, and cosmic rays, takes over. But what lay beyond that? Leela's mind raced with possibilities. The closest star to our solar system is Proxima Centauri, a red dwarf located 4.24 light-years away. Leela often imagined what it would be like to travel there. At the speed of light, it would take over 4 years, a journey far beyond our current capabilities. But the dream of reaching Proxima Centauri and its exoplanet, Proxima b, fueled her imagination. Proxima b, discovered in 2016, orbits within its star's habitable zone, where temperatures could allow liquid water to exist. "It's a tantalizing target," Leela said in a lecture. "But we don't yet know if it has an atmosphere, or if it's truly habitable." The conditions on red dwarf planets can be harsh, with intense stellar flares and tidal locking, where one side always faces the star. Still, the discovery of Proxima was a milestone. It showed that Earth-like planets could exist just next door, in cosmic terms. Leela dreamed of the day when we might send a probe to Proxima, perhaps even a crewed mission, to see it up close. The discovery of Proxima was just the beginning. Over the past 2 decades, astronomers had found thousands of exoplanets, worlds orbiting other stars. Leela remembered the excitement when the Kepler Space Telescope launched in 2009, its mission to find Earth-sized planets in the habitable zones of their stars. Kepler's discoveries were staggering. There were hot Jupiters, gas giants that orbited close to their stars, and super-Earths, rocky planets larger than our own. Some systems, like TRAPPIST-1, had multiple Earth-sized planets, each a potential candidate for life. TRAPPIST 1 is a red dwarf star with 7 planets, Leela explained in a documentary. 3 of them are in the habitable zone. Imagine standing on one of those worlds, looking up at a sky filled with neighboring planets, each as large as the moon in our sky. But not all exoplanets were Earth-like. Some were bizarre, defying imagination. There was HD 189,733 bits, a blue planet where it rained molten glass, and WASP 12 bits, a world so close to its star that it was being stretched into an egg shape. The diversity of exoplanets is astounding, Leela said. It shows us that the universe is far more creative than we ever imagined. Beyond exoplanets, Leela was fascinated by the birthplaces of stars, nebulae. These vast clouds of gas and dust were the cradles of new solar systems. She often showed her students images of the Orion Nebula, a glowing region where stars were being born. Inside these clouds, gravity pulls the gas and dust together, she explained. As it collapses, it heats up, and eventually, a star ignites. The leftover material forms planets, moons, and asteroids. One of her favorite stories was about the Pillars of Creation, towering columns of gas in the Eagle Nebula. Made famous by the Hubble Space Telescope, they were a symbol of the beauty and violence of star formation. Those pillars are being eroded by the radiation from nearby stars, Leela said. But even as they're destroyed, new stars are forming within them. It's a cycle of creation and destruction that's been happening for billions of years. As Leela delved deeper into the cosmos, she encountered one of its greatest mysteries: black holes. These regions of space-time, where gravity is so strong that not even light can escape, fascinated and terrified her. Black holes are like cosmic vacuum cleaners, she joked in a public lecture. But they're also laboratories for testing the laws of physics. In 2019, the Event Horizon Telescope captured the first image of a black hole shadow, a ring of light surrounding the dark heart of the galaxy M87. Leela remembered the excitement in the scientific community. It was like seeing the unseeable, she said. A black hole is the ultimate cosmic mystery, and we were finally getting a glimpse of it. But black holes were not just destructive. They played a crucial role in the evolution of galaxies. Supermassive black holes, like the one at the center of the Milky Way, influenced the motion of stars and gas, shaping the galaxy itself. We're still trying to understand how black holes form and grow, Leela said. But one thing is clear. They're at the heart of the cosmic dance. On the largest scales, the universe was a web of galaxies, connected by filaments of dark matter. Leela often thought about the cosmic web as she analyzed data from telescopes like Hubble and the James Webb Space Telescope. The cosmic web is the skeleton of the universe, she explained. Galaxies form along these filaments, like beads on a string. The spaces between them are vast voids, almost empty of matter. Dark matter, which made up about 27% of the universe, was invisible, detectable only through its gravitational effects. Leela was part of a team studying dark matter's role in the formation of the cosmic web. We don't know what dark matter is, she admitted. But without it, the universe as we know it wouldn't exist. It's one of the biggest mysteries in science. For Leela, the ultimate question was whether we were alone in the universe. The discovery of exoplanets had brought us closer to answering that question, but the search for life was still in its infancy. We're looking for biosignatures, signs of life, like oxygen or methane in a planet's atmosphere, she explained. But we also need to consider the possibility of life that's very different from ours. She was particularly excited about Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn. Both had subsurface oceans that could harbor life. Imagine a world where life exists not on the surface, but in the dark, icy depths, Leela said. It's a reminder that life might be more resilient and diverse than we think. As Leela stood on the roof of her grandmother's house once more, now a renowned scientist, she felt a sense of awe and humility. The universe was vast, filled with wonders beyond imagination, and humanity had only just begun to explore it. What lies beyond our solar system? She whispered to the stars. The answer is out there, waiting to be discovered. And as she gazed into the infinite horizon, she knew that the journey was just beginning. Leela's story is a testament to the power of curiosity and the human spirit of exploration. From the edge of our solar system to the farthest reaches of the cosmos, the quest to understand the universe is a journey that unites us all. As we look to the stars, we are reminded of the words of Carl Sagan. Somewhere, something incredible is waiting to be known. And so the search continues, driven by the same spark of curiosity that lit up Leela's eyes on that starry night so many years ago. As Leela delved deeper into her research, she encountered one of the most perplexing mysteries of the universe: dark energy. Discovered in the late 1990s, dark energy was the force driving the accelerated expansion of the universe. It made up about 68% of the universe, yet its nature remained elusive. Dark energy is like a cosmic repulsive force, Leela explained to her colleagues. It's causing galaxies to move away from each other at an ever-increasing rate. But we don't know what it is or where it comes from. She often thought about the implications of dark energy. If the expansion continued to accelerate, distant galaxies would eventually move beyond our observable universe, leaving future civilizations with a much smaller cosmic neighborhood. It's a reminder of how little we know, Leela said. But it's also an opportunity. Understanding dark energy could revolutionize our understanding of the universe. One evening, as Leela pored over data from the James Webb Space Telescope, she found herself contemplating the multiverse hypothesis. The idea that our universe might be just one of many was both thrilling and daunting. The multiverse is a controversial idea, she admitted in a lecture, but it's rooted in some of our best theories, like quantum mechanics and string theory. If it's true, there could be an infinite number of universes, each with its own laws of physics. She imagined what those other universes might be like. Some could be similar to ours, with stars, planets, and perhaps even life. Others might be wildly different, with dimensions we can't comprehend or forces we've never imagined. The multiverse challenges us to think beyond our own universe, Leela said. It's a humbling reminder of how much we have yet to discover. Leela's curiosity about life beyond Earth extended to the search for extraterrestrial intelligence, SETI. She was fascinated by the idea that somewhere out there, other civilizations might be looking for us, just as we were looking for them. SETI is about more than just finding aliens, she explained. It's about understanding our place in the universe. If we find evidence of another civilization, it would change everything. She often thought about the Drake equation, which estimates the number of active, communicative extraterrestrial civilizations in the Milky Way. The equation included factors like the rate of star formation, the fraction of stars with planets, and the likelihood of life developing intelligence. The Drake equation is a way of framing the question, Leela said. But until we find evidence, it's just speculation. That's why SETI is so important. It's a search for answers. As Leela looked to the future, she felt a sense of excitement and urgency. The next few decades promised to be a golden age of space exploration, with missions to Mars, the outer planets, and beyond. We're on the brink of a new era, she said in a TED talk. Missions like the James Webb Space Telescope, the Europa Clipper, and the Mars Sample Return are just the beginning. We're also developing new technologies, like fusion propulsion and space elevators, that could take us to the stars. She dreamed of the day when humans would set foot on another planet, perhaps even an exoplanet. It's not a question of if, but when, she said. And when that day comes, it will be a new chapter in human history. Leela often reflected on the legacy of exploration, from the first humans who looked up at the stars to the scientists and engineers pushing the boundaries of knowledge today. The quest to understand the universe was a shared human endeavor. Exploration is in our DNA, she said. It's what drives us to ask questions, to seek answers, to push beyond the known. And it's not just about science. It's about inspiration, about dreaming of what's possible. She thought about the young girl she had been, gazing at the stars from her grandmother's roof, that spark of curiosity had led her to a life of discovery, and she hoped to inspire the next generation of explorers. The universe is vast and full of mysteries, Leela said, but it's also full of beauty and wonder, and as long as we keep exploring, we'll keep finding new ways to understand it. As Leela stood on the roof of her grandmother's house once more, now a renowned scientist, she felt a sense of awe and humility. The universe was vast, filled with wonders beyond imagination, and humanity had only just begun to explore it. What lies beyond our solar system? She whispered to the stars. The answer is out there, waiting to be discovered. And as she gazed into the infinite horizon, she knew that the journey was just beginning. This continuation of the story delves deeper into the mysteries of the universe, exploring concepts like dark energy, the multiverse, and the search for extraterrestrial intelligence. It maintains a balance between real scientific information and a narrative that inspires curiosity and wonder. The story concludes with a reflection on the legacy of exploration and the endless possibilities that lie ahead.